Hi friends, here is a beautiful problem. We have to find out what is the sum of coefficients of a plus b whole power 6. We actually don't need to expand this to find out what is the sum of coefficients. For example, let's say we have a plus b whole square. Right. This is what is this? A square plus 2ab plus b square. What is this? What is the sum of coefficients? Coefficient of a square is 1. 1 plus 2 plus 1. Right. This is sum of the coefficients which is actually equal to 4. Now, if let's say if A equals B, A and B both are ones, basically 1 plus 1 whole square. What does that mean? This becomes 1 square plus 2 times 1 times 1 plus 1 square. Right. What does that mean? See, these numbers, when these are ones, they don't add anything. So the sum of coefficients is 4. At the same time, 1 plus 1, 2. 2 square is actually equal to 4. Because in this multiplication, because everything is 1, 1 square doesn't add anything. This 1 and 1, because it is again 1 and 1, these also don't add anything. Plus 1 square also, it is still 1. Right. So this equals actually 1 plus 2 plus 1 only. What we are doing when we are replacing A and B with 1 and 1, the sum of coefficients is actually 2 square. Similarly, a plus b whole cube also. Whole cube, if you want sum of coefficients, a cube plus 3a square b plus 3ab square plus b cube. Even if you don't know this formula, the sum of these coefficients would be when a equals 1 and a equals 1, comma b equals 1. When both are ones, what will be left? Will be left all with the coefficients. Right? Because a cube doesn't add anything. Right. A cube here it is anyway 1. 1 into a cube is still 1. Similarly, 3 a square b, whatever, because a square b is again 1. So we'll be left with 3. Similarly, ab square, it is again 1, we'll be left with 3. Similarly, b cube, this is again we'll be left with b. So basically, a plus b whole cube when a equals 1 and b equals 1 will be equal to the sum of coefficients of the expansion. Right. So what is sum of coefficients in a plus b 6? B power 6. This is 1 plus 1 4 power 6. This is 2 power 6 which equals 64. Right. This is this is so simple. But we should know what is a plus b whole power 6 also. We know our binomial theorem. What does our binomial theorem says? X plus a whole power n equals x power n plus nc1 into a, which is a power 1 into x power n minus 1. So this 1 we add 1 to a and you subtract 1 for x plus nc2 a2 times and x n minus 2 times plus nc3 a3 times x n minus 3 times. Right. Likewise, we do until ncn plus ncn a n times and x n minus 1 n times x n minus 1, which means x power 0, which is equal to 1. So we remove this. Similarly, x power n means nc0 a power n minus n. A power 0, sorry, a power 0. This means nc0 a power 0 x power n. A power 0 is 1 and nc0 is 1. So we are removing this. So this is the expansion by our binomial theorem. Right. It applies to any power as long as n is integer. For example, x plus a whole square. And this x square, x power n is x square plus nc1. 2c1 is 2. 2 into a power 1, which is a. X power 2 minus 1, which is again x. Plus 2c2. 2c2 is again 1. And a power 2. Right, NCN is again NC2. So here we have only three terms. X power If this is power 4, power 3, we have 4 terms. Power 4, we have 5 terms. Right. So, what we are talking about, if it is a plus b whole power 6, then we are talking about coefficients as NC0, NC1, NC2 plus NC3. We have 7 terms. Right. 1, 2, 3, 4. This NC4, NC5 plus NC6. 2, 3, 4, 5, 6, 7. Right. What is N? What is N here? N is obviously 6. 6C0 plus 6C1. Basically, we are talking about 6C1, 6C2, 6C3. We already know what is 64. 64 is again 6C2, right? 64 is again 6C2. And 6C5 is again 6C1 is equal to 6C1. NC1 equal to NC n minus 1, right? So, similarly, plus 6C6, 6C2, which is 6C0. Right. This is what we want. There are 7 terms 1, 2, 3, 4, 5, 6, 7. What are the 7 terms? 1. NC0 is 1. NC1 is a 6C2. 6 into 5 by 21, which is 10. Right. Here this is 6, 5, 4, 3, 2, 1 by 4 is 20. Right. 20, again 15, again 6, again 1. Right. The sum of all of this is again 64. 20 plus 30, which is 50, 62, 64. Right. This is also equal to 64. This is by way of expanding any polynomial a plus b whole power n using binomial theorem and then calculating all the coefficients. But this is a very long method. Still, we should know this. We should know how to expand a polynomial, right, using binomial theorem. But very shortcut, whenever we want coefficients, just let's put 1 and 1, that's it. Because when they are ones, they don't add anything to the sum. The sum is only the sum of coefficients when they are ones. Right, guys? Thank you.